I think I resolved all the issues with YouTube. So I may be the only one in the world who knows how to do this. So what I figured out on my own is that because I'm trying to protect you folks from being exposed on the internet, right? So what you do is you make it unlisted so nobody can find it by a Google search. But then nothing was showing up even to you folks. So then the playlist, if it's in a playlist, it's supposed to, but I wasn't doing that. So if I made the playlist itself public and all the videos inside the playlist are unlisted, then all the unlisted videos are still available to you. So they won't be able to search for individual videos. I mean, it's doubtful that they would search for Unit 2 type of information. So I think it's probably okay. Does anybody have any questions about anything else about the course, syllabus, or anything? So I think what I'm going to do is share the screen and start at the beginning of chapter 1. And I'm just going to like scroll. And you guys just stop me anytime to see if you have any questions. And while we're doing this, you might think about this. There's really two kinds of questions that you could have on an exam. One is simply a mathematical problem. It's a word problem, right? How many centimeters are there and how many gigameters or something? So those have mathematical solutions. And the other kind of problem is an objective type problem. Most of the time, these are in the form of multiple choice questions. Oftentimes, I prefer true-false ways. And those are all the things that there's no real mathematical answer to. So for example, I could say, this number right here has four significant figures, and the answer would be yes or no, true or false. There's not a real calculation, if you know what I mean. So scientific notation and your calculator. So that's just really trying to, knowing how to do mathematical manipulations in scientific notation on your calculator. Let's see. And then the direct proportion. If you understand what a direct proportion is, which if you look at all these lines, there's only one, that's the blue one, right? It's a straight line that passes through the origin. And the slope of that line, because the equation is y equals mx, because b is equal to 0, the slope of that line is the conversion factor. So if you're looking at the graph, if you want to convert, say, from 2 meters into centimeters, you have to use the slope of this line right here to get it. So mathematically, that line is described as y equals mx. Here, b is 0. So here's x, here's y. What do you need to get to change between them? Is m, the slope of that line.
Isn't that the same for non-direct proportions? Like you go up from the x to the line and then you can go to the y?
Sure. You could do that here, right?
Yeah.
But then that's not a direct proportion because that's a different equation. Same thing here, it's a different equation. So you can't use the same criteria here as you can over here.
Oh, right.
You know what I'm saying?
Yeah.
So here's what,
The direct proportion would have to be a straight line throughout the graph,
and it has to pass through the origin.
and it has to pass through the origin. Okay.
Yes. So here's the letters that you need to have memorized before the exam. And then here's, you know, in between the two different systems, you should know one of those. So here's your last one. That's the 14 conversion factors that you're supposed to know for the first exam. Then it was simply how to write conversion factors. And then the methodology using the units to set the problems up. So here's some conversions we did in the square and cubed.
Actually,
I have a question on that.
Okay.
So I can see, like, I can see how you do it on here, but I can't get my calculator to give me the right answer. So I'm assuming I'm entering it incorrectly. Like, I can do it on paper, but I can't check my answers.
Okay, well, what color calculator are you using? Oh.
A beautiful pink one.
Yeah, that's a problem. Okay, so you're able to get this, right? 6.4516 by multiplying
Yes.
that. But you're not able to get this part?
Sorry, I wrote this down as a question, but I apparently didn't leave myself a lot of notes.
Okay. So mathematically, you're just taking 55.5 and dividing by 6.4516.
Okay. And we're not dividing it by the one then?
Not dividing it by what?
The one on the numerator?
No, because that's one just doesn't do anything to change the number.
So if I was going to put it in my calculator, I would just do 55.5 multiplied by 6.4516.
No. So like this first one right here is understood to be written over 1, right? There'd be a 1 down here if I had it in the same style as this. So on the top, you're going 55.5 times 1, and on the bottom, you'd be going 1 times 6.45. Then you take whatever you have on the numerator and divide by the denominator, and then you would get that.
And how would I enter that into a calculator to check my answer?
Yeah, so you don't need to do this multiply by 1 part. So it's just 55.5 on the numerator, then divide by 6.4516, and then you should get 8.6.
Okay.
Another way you might do it that I can do on my calculator is putting in the parentheses.
Mhm. Yeah, everybody has a different calculator. And
Yeah, no, sorry, that works. I was confusing myself earlier.
Mhm.
And then I guess I got confused as well with the volume. Are these the top of page 13 and the bottom of page 13 and the top of page 14? Is that for the same equation? It is, yes.
Yeah, that's a continuation.
Okay.
Right.
Sorry, I think I see what I was doing. I just couldn't figure out where the 5.7 came from, which it's literally in the equation, so ignore me. Sorry.
Yeah. So I think you got it now because you're just not used to seeing it written this way. But one way to look at it is like, this is the style. It's just over 1. This could be written as over 1 as well. And then you're multiplying the numerators, then you're multiplying the denominators, then you're doing the division. But
Okay.
mathematically, to do this part, I just go 5.7 times 10 to the 3, and I should get that same answer there.
Great.
Okay, well, let's go on to the temperature scales. So you might already know that what I'm trying to do when I teach stuff is I try to get you to understand it. I don't want you to memorize it. Personally, I can't memorize stuff. That's why I'm not good with when is the exam. I'm not going to memorize what's on there when I can look it up. So anyway, it's based upon physical properties of water. In other words, the boiling point and the freezing point. So in the real situation, you have to have a whole bunch of other things controlled, right? Like the humidity, the pressure, all that kind of stuff. But that's all understood to be done. So if you look at water, the freezing point in the Fahrenheit scale is 32. And the boiling point in the Fahrenheit scale is 212. But if you use the centigrade or Celsius scale, the freezing point is 0, the boiling point is 100. So this is named the Celsius scale. Celsius is a dead guy. His name was Celsius. But it's also called centigrade because between 100 and 0, there's 100 divisions, right? And over here, you don't have 100 divisions. There's 180 divisions. So, but the distance on the thermometer, on the mercury, here is cut into 100 divisions. Here it's cut into 180 divisions. So you can see that one division in Fahrenheit is going to be smaller than a division in centigrade, right? Now, if we look at Kelvin, Kelvin was based upon the centigrade scale. So there's 100 degrees difference between the freezing point and the boiling point. Okay, so you can see already that 0 degrees Celsius is 273.15 degrees Kelvin. So now let's look at the equation. Here's the equation that you used and all throughout your school so far. And you had to memorize the equation and you had to input one thing and then calculate for the other. So why is it that you always had to use the equation? It's because it's not a direct proportion. This 32 right here represents B. So this would be Y is equal to mx plus B. And B is not 0, so it's not a direct proportion. So now how do we reconcile this equation? Instead of having you just memorize it, I want you to understand it. So if you look back here again, the same distance between the boiling point and the freezing point is 180 degrees Fahrenheit, but it's also 100 degrees centigrade. So they're equal to each other. So now if I take that equality, I divide both sides by 100 degrees centigrade, for example, I would get this. But 100 degrees centigrade divided by 100 degrees centigrade is equal to 1. So therefore, this relationship right here is also equal to 1. It turns out that's the slope of the line. You can see it has 1.8 in there, but where'd that come from? Okay, well, we have 180 degrees Fahrenheit for every 100 degrees Celsius or centigrade. If I divide top and bottom by 20, I get 9 and I get 5. If I take 9 divided by 5, or if I take 180 divided by 100, I get 1.8 over 1. The problem is mathematicians, most scientists don't use the units. So this should be 1.8 degrees Fahrenheit divided by 1 degrees Celsius, which is the slope of that line. Then what do I do about this not being 0? Well, this turns out to be B. So if I were to graph it, here is on the X is centigrade, on the Y is Fahrenheit. If I'm looking at this equation right here, what happens at 0 degrees Celsius? If that were 0, then this cancels out, and then F would be equal to 32. So at 0, F is equal to 32. That's B. And the slope of the line is 1.8 degrees Fahrenheit for every 1 degree Celsius. But because this does not pass through zero, it's not a direct proportion. Therefore, to solve problems with it, you have to always use the equation to compensate for that 32.
Professor, why did you divide 180 and 100 by 20? Why is the number 20?
I did that because a lot of people are used to memorizing it this way. It's 9/5.
Okay.
That's the reason why. But if you take 9
Okay.
divided by 5, you get 1.8.
Okay, thank you.
So I wanted you to see the origin of how the equation was put together. So here's the equation for converting between Kelvin and centigrade. So look at the way they write it right here. If you're thinking, okay, it's a straight line, so here's y is equal to mx plus b, I can see that this is b right here, but where the heck is m? They simply left it out. They ignored it. If you go back up here, you'll see that the size of a Kelvin is the same as the size of a Celsius. Between these two marks on the thermometer, there's 100 divisions in Kelvin and 100 divisions in centigrade. The size of the units are the same. So that means that this right here is the equivalent. If you divide one by the other, you simply get 1. So because it turned out to be 1, they left it out of that equation that they have everybody memorize. And nobody seems to understand that that is simply y is equal to mx plus b. What's the equation for a straight line? Y is equal to mx plus b. And I'm sorry, I know I came into academics late, science late in my life, and I question things, and I look at this kind of stuff. It's like, why do they do this stuff? This is counterproductive to teaching people about a straight line. The math in chemistry should be the same as the math in math. So people are not teaching for understanding. They're teaching for memorizing and passing the test. But I'm not going to do that. So I know you know how to do this stuff. So given the equation, which I will not make you memorize, convert negative 44 Celsius into Fahrenheit. Okay, so how do I do that? So I have the number for Celsius, so I simply substitute it in there, and then I do the math, and then there's the answer. Negative 48 degrees. Now we go the opposite direction. Convert negative 222 Fahrenheit into Celsius. So what I did first is I rearranged the equation. I did the algebra first, and then I substituted. What I notice students try to do is they try to substitute and then rearrange the equation. It makes it more complicated. So I would say simply get this right here and then put your numbers in. Okay, so simple algebra. So now I'm substituting negative 222. And so notice you have a negative, then you're subtracting 32 from it. You get a negative number. Then when you divide by 1.8, it's still a negative number. So convert negative 222 Fahrenheit into Kelvin. Well, we didn't memorize an equation to do that. We could come up with one, no problem. But it's easier just to do it 2 steps. First, go from Fahrenheit into Celsius, like how I did here. And then once you have Celsius, you simply add 273.15 to it, and then you get your number. If you ever come up with a negative degrees Kelvin, you know you did it wrong. So 0 degrees Kelvin corresponds to the absolute lowest temperature possible. It represents 0 kinetic energy. And when does that happen? At minus 273.15 degrees Celsius. At this temperature, there's no atomic motions. So if you look at a solid, at the room temperature right now, these things are vibrating all around in place, but they can't move from point A to point B because they're held together by attractive forces. And the lower the temperature, the slower these things start to vibrate. When you get to 0 degrees Kelvin, there's no vibrations, no molecular or atomic motion. But here's something I'll throw in here just to make you think. What happens to the electrons inside the atom? Do they stop? And the answer is no. Electrons are still moving below the speed of light, but they're still moving close to the speed of light. They're booking. If the electron were to actually stop, it would be sucked into the protons in the nucleus, and all things would be converted into neutrons, and all you would have would be neutrons. So I'm pointing this out for a reason. The electron is a fundamental particle. It cannot be broken down into anything else. A proton, for example, can be broken down into an electron and, did I say that right? A neutron can be broken down into an electron and a proton. And a proton can be further broken down into different quarks and other subatomic particles. The electron is a fundamental particle. And what we just described right here is one of the major things I want you to think about, because this is the kind of thing that makes science interesting. The fundamental particles do not obey the laws of physics in the same way that we have to. Pretty interesting, huh? So space is not 0 degrees Kelvin. It's about 2.7 Kelvin. But in 1995, physicists produced temperature that was just a fraction of a degree Kelvin. In other words, they were able to create in the laboratory things that were colder than outer space itself. When that happens, you get to that place, it's called the Bose-Einstein condensate, and that's where all the electrons have the same spin. All the atoms start to act as the same, and you really get a fifth state of matter, and this is where superconductivity starts to happen. So how do you do this? Well, you decrease the kinetic energy. So here's kinetic energy described in the equation for, the physics equation. So kinetic energy is equal to 1/2 times the mass. Now both 1/2 and the mass should be a constant, right? And V stands for velocity or speed. So what happens if I increase kinetic energy? I increase the speed of the particle. So what they do is concentrate on trying to reduce the velocity or the speed of these particles. So the first method, they use magnetic fields to dampen the velocity. Like I was saying, in a solid, the particles are bouncing all around, right? So they were using magnetic fields to dampen it this way and then dampen it that way. And as you lowered the velocity, you lowered the kinetic energy, which is directly related to the temperature. And then they got laser cooling down. So they used lasers to dampen the frequency of these atomic motion. And they got pretty close to 0 degrees Kelvin. Okay. So here's where they are now. That's pretty much 0 degrees Kelvin. So here's some temperatures found on Earth. So the crust is about 5 miles under the oceans, about 25 miles under the continents. At the bottom is about 1600 degrees Fahrenheit, and then the mantle is hotter. The core is even hotter. Then I just use that to do some conversions that hopefully you would try those conversions and see if you have the same answer. Then this part right here is practicing. You know what I just realized? I didn't record the video. The record button isn't visible. Oh, I did do that. Sorry. Forgot that I did that. So here's a bunch of practice problems, and they're all worked out step by step. And why did I do this? Do you think it's because I had nothing to do on a Saturday night and I needed something to do, so I just did this? Maybe I did it because what I want you to do is this on your own. So here's the problem. Don't look at what I did. See if you can get the same answer. And I used the methodology that was going to be used throughout this entire course.
I have a question.
Yes.
So in this equation, like let's say this was on our test, we would need to know like the difference between a microgram, 10 times, I don't know, -3, like, compared to a gram, compared to a megagram, which is like 10 to the 12th or something. Like we need to remember, like have that all, like that's what you were talking about, right? Like we need to know.
Right. You need to know what M stands for. And you need to know what micro stands for.
Right.
Right?
Yeah.
So you can come up with these conversions.
Okay.
So it's really 1/1,000,000th of a meter is equal to 1,000,000th of a gram. See the point?
Yeah. Okay.
Okay. So the rest of this chapter, I think, is kind of, I'm trying to make you think different ways. But I've always been concerned about students not passing this, like they don't get it. And why are they not getting it? And I think it goes all the way back to the very, very basic education that you were exposed to. And I guess I was really greatly influenced by my one uncle. My one uncle actually got a degree in chemical engineering after the Korean War, but he wasn't interested in chemistry, so he went into education, got a PhD. He was a teacher at Punahou, and then he's one of the ones that founded the Research Development Group, Curriculum Research and Development Group. And he wrote a book or two that were very important way, way back in the 60s. Anyway, CRDG started writing all this curriculum. It was science-based because my uncle was originally interested in science. And so one of my kids actually had that textbook in intermediate school that was written by the UHCDRG. And then I knew a teacher that worked there in the lab school where they actually experimented with curriculum. And I was observing some stuff and I realized that what they were doing was just so important. So for example, you're talking about kindergarten, right? You take the kids out to the garden every day at the same exact time. You make them read the thermometer that's sitting there. And then they go back into the school room and they record it. And what they're seeing is that, oh, the temperature goes up and then it goes down in a seasons, right? So from the very beginning, they're teaching them that real observation And a mathematical form of a graph is real. It's not anything unusual. And I think that's not taught anymore. And that whole concept of making things real is gone. Now it's just memorize stuff and get through the exam. So students, don't make the connection between basic concepts and applications of them. So here's what I mean. Everybody in this class can do these kinds of problems. Why? Is this a direct proportion right here? $10 an hour, you work 8 hours, you get 80 bucks. That's a direct proportion. No student is going to have a problem doing that kind of math. Then you go a little bit further, as I go centimeters. You may not know exactly what a centimeter was, but you can still do it. So what about if you do something, I want to say out of the box, but then I'm going to use the box here. So Vet is able to fill a box with 44 Chihuahuas. He's able to fill that same box with 33 Dachshunds. So what is the conversion factor between Chihuahuas and Dachshunds? And people are thinking, well, you can't convert a Chihuahua into a Dachshund. And I'm like, yes, I can. Why would it be different than this? Oh, you can't convert a meter into a centimeter. So what we're saying here with this problem is that 44 Chihuahuas is equal to 1 box, and 33 Chihuahuas is equal to that same box, so therefore 44 Chihuahuas is equal to 33 Dachshunds. That's inequality. Is it a direct proportion? Well, if I had 2 boxes, there'd be 66 Dachshunds and there'd be 44 Chihuahuas, right? So anyway, I'm going to take this mathematical relationship, I divide both sides by Chihuahuas. So 44 Chihuahuas divided by 44 Chihuahuas is equal to 1. So therefore, this part of the equation is also equal to 1. So now we can convert between Chihuahuas and Dachshunds. So how many Dachshunds and 3,000 something Chihuahuas? So I write down the thing to start with, and then here's my conversion factor. I got to get rid of Chihuahuas. I got to keep Dachshunds, and there's my answer.
Excuse me, Professor.
Yes.
I was looking at this equation here, and I was wondering, could you, to simplify the conversion factor, could you divide the Dachshunds by the Chihuahua? So, for example, 33 Dachshunds divided by 44 Chihuahuas would be 0.75. So could you say, for example, that 0.75 Dachshunds, could you write 0.75 Dachshunds over 1 Chihuahua?
Yes, you could.
As part of it. Okay.
That would be mathematically equivalent.
Okay. All right.
Just like you can say 66 Dachshunds over 88 Chihuahuas.
Yes.
And
And then that would help solve for the equation. Yeah.
Yeah. And because it's equal to 1, the inverse of 1 is 1. So you just can do the inverse as well. You can do whatever you need to solve that particular problem.
Okay. Okay, thank you.
Mm-hmm. Here's another one. How many platypuses in 8,000 Chihuahuas, if there's 10 Chihuahuas equals to 1 platypus? So I got that many Chihuahuas. I got to get rid of Chihuahuas, keep platypus. So the 10 is associated with the Chihuahuas, the 1 with the platypus. So there's my answer. And I graphed it. So you got, say, 10 Chihuahuas and 1 platypus. You got 20 Chihuahuas and 2 platypus, right? It's a straight line passing through the origin. And what is the slope of that line? Well, I calculated it. It's 10 Chihuahuas per platypus. Same thing we came up with up here. And that's a Chihuahua and that's a platypus. And I don't know what's going to happen when I click on this video. We'll see. I have no idea what's going to happen. And if you can see this or not. Can you see this?
No.
Okay. I go stop screen share. Come on. Let me screen share again. Now you can see it. So yeah, what my whole point is that that's a platypus. That one's not. No, I don't know how to get back there. Well, anyway, you can go look at the video yourself if you want. It's not important. It's just that I just think platypus is the coolest animal ever invented. So the reason why I got into platypus is because for my other class, my biochem class, when I teach genetics, I found an article where they had just sequenced the gene, the entire genome of the platypus, and it had genes from all over the walks of life. So it has genes to make milk. In other words, it's a mammal, but they lay eggs like a snake. They have venom. Back on a spur over here where the males used to fight each other. Because males are always so smart. So it has genes that are similar to snakes because of the venom. It's got web feet with claws. It's got a bill and web feet like a duck's. So it's got genes from birds, genes from mammals, genes from reptiles. It's just the most unusual thing. And by the way, humans, we have two genes or two chromosomes essentially that determine sex, right? Although they don't often do a great job with that. Well, they suspect that the platypus has 10 chromosomes that are involved in determining the sex. So here's another one. So a chemistry student can't find a ruler in the lab, so he finds a stick and uses it to measure the device as 2.5 sticks. So then later on, he measured the stick that he was using was 150 centimeters long. So this reminded me one time I was a carpenter's apprentice, and I was left on the job site alone. I was told I got to do this and this and that, and I couldn't find my tape measure. I think I left it in the truck. And so my choice was to sit down and do nothing for the entire workday or to find a workaround. So what I did is I found a stick, and for that whole day, I used that stick to measure everything. Later on, I worked with a carpenter that they had brought in from Japan. He hardly ever used a ruler. He was a finished carpenter. He would take the work right up to where he wanted it, make a pencil mark, and he would know which side of the pencil mark to saw. It was crazy. He could build a house without nails. So what I'm trying to get you to think about is this. One stick was equal to 150 centimeters. So if something was 2.5 sticks long, how do I convert that into centimeters? Well, I need to cancel out the stick, keep the centimeters, and then there's my answer. What's the conversion factor between centimeters and meters? So one stick was equal to 150 centimeters, but that's also equal to 1.5 meters. So now I only care about this relationship between centimeters and meters. Okay. So I take this, here I divide both sides by 1.5 meters. That cancels out, is equal to 1. So there's my conversion factor right there. So once you understand how the math works, you can do it, you can apply it to almost anything. So the adult human brain contains about 100 billion neurons. Each neuron makes about 1,000 connections to other neurons. So how many connections are there in the human brain? So what am I starting with? Here's 100 billion neurons, right? So 100 billion neurons. So now I need a conversion factor. So every neuron has about 1,000 connections. So I'm canceling out neurons, keeping connections. There's the number of connections. They estimate that there's 100 billion galaxies in the universe. That's about 10 to the 11th galaxies in the universe. It's also estimated that there's 70 billion trillion stars in the universe. So 70 billion trillion stars, or 7 times 10 to the 22 stars. So how many stars in the average galaxy? Well, what do we want? We want the number of stars divided by the number of galaxies. See how the units are setting this problem up for me? There's the answer. So by the way, from this estimation, there's about 7 times 10 to the 22 stars in the universe. And what was a mole again? What was Avogadro's number? 6.022 times 10 to the 23. So I'm hoping you're getting kind of a perspective here. If I go to the periodic table and look at these numbers again, like for hydrogen, right? So for hydrogen, the number right there is 1.00794. What that means, if I had 1 mole of hydrogen atoms, it would weigh 1.00794 grams. And in that 1.00794 grams, there would be 6.022 times 10 to the 23rd atoms of hydrogen. A gram is a very, very small amount. I don't have anything close to show you, but it's just a very small amount. And there's more atoms of hydrogen in there than there are stars in the universe, by a factor of about 10. So right now, you should be able to do homework 1 and the first page of homework 2. Anyway, so any questions so far?
Homework 1 and homework 2 is that in the resources page of La Lima?
Yes, it is. And I did not load up the those in the tests and quizzes yet because I don't want you starting it and then realizing that you don't know what you're doing. I want you to do it on paper first and give a little bit more time. And I'll put them up. I'll make them available maybe tonight or something.
Okay.
Yeah.
And what is the due date?
Oh, I'll try to put it on there. You'll see it.
Okay.
So what about graphing? And anyway, it's in the prerequisites. People are supposed to be able to do simple graphs. Then when I actually had students try to do a simple graph, I realized that most of them can't do it. They have no clue what they're doing. So I think this is very important. And there's a lot of other reasons why I do this. Anyway, first we have to get the graph. So you have to decide which one is X, which one is Y. So here's the data that we're using here. So X is seconds and Y is meters. So why did I choose X as seconds and not meters? It's because the slope is the change in Y divided by the change in X. So the change in meters divided by the change in seconds, that makes more sense than the change in seconds divided by the change in meters. Because meters per second we know is a rate, right? That's something that is in our everyday experience. So you get a piece of graph paper and you make marks on it, and you want to use as much of the page as possible. So let's see. I have graph paper over here. I have all this specialized graph paper that nobody uses anymore, because we have computers. So one day you'll show a piece of graph paper to someone, they have no idea what that is, they've never seen it before. But my point is this: you could make your graph this big, but there's a way to make it much bigger. So if you were to use it this big, when you put your data on here, you'll be able to get more substantial numbers off of the graph paper. So what you want to do is figure out how many spaces there are for one unit of whatever you're doing to use as much of the graph paper as possible. So then you plot your points, okay? And looking at this right here, you can already see that, well, if x is 0, y is 12, that doesn't look like it's going to pass through the origin, so it's not a direct proportion. And then you draw a single straight line through the data points, treating each point as equal. So if I had something like this, say I just had something like this. I don't do this. Why do I not do that? Because that's a whole bunch of different lines, isn't it? And they all have different y's and x's and slopes. So what we do is we take a straight edge, which here's a straight edge, and what I'll do is put this straight edge something like this. I don't know if you can see that or not, but I move it around so I can get the average of all the points. I'm giving all the points equal importance. When I draw the line, it's a single straight line, which I'll do in a different color here. Can you see that? Folks can see that?
Yes.
Yes, sir.
So I treated every point as equal importance, and I didn't put the graph, the line on one point and then swing it around so the other points can fit. And now I have one line, I'll have one slope, and from now on, I don't care where the data points are. I ignore the data points. All I care about is the line itself. So when I'm asked to get the equation of the line, I ignore the data points. I never use them again. I want the information about the line. So pick 2 points on the line to calculate the slope. So here I did that. Then you read off of the graph to get the intercept. So B is right there. And the slope is from the line. I just read off of the graph to get the slope. To get the intercept. I take 2 points on the line to calculate the slope of the line. I can't use data points because that's going to be different.
And Professor, this is not, in this example in particular, even though X is 0, it's still not a direct proportion. So both X and Y have to be 0 in order for B to be considered an origin. Is that correct?
That's exactly right. Yep.
Okay.
Yep.
Okay.
So anyway, now I have the slope that I calculated. I have the intercept, the B that I read off of the graph, and now I have the equation for the straight line. Okay. Once I have that, I can do equations. I can calculations. So how many meters after 25 seconds? Okay, so here's the equation for the straight line, right? So I'm putting in 25 seconds here. You see seconds cancels out and I get meters. Add that to the other meters from B, and here's the answer. So you also can do this with the least squares fit program, which is what I actually did here, I believe. But anyway, here's the data I got from the least squares fit program. And here's a graph that I did here. Okay. So at this point, you should be able to do homework 3. Okay. The graphing. Okay, so any questions so far?
So, excuse me.
Mhm.
How to calculate, how to get the slope? I can choose any the different points, right?
Any 2 points, on the line, right? So you could take that point there. You could take this point here because that looks like it's on the line, or that point or that point.
But not the data shows on the.
Up
I
here,
mean, yeah, not choose this data, right?
cannot take
Just choose some the
these
integer, something like that.
because this is going to give you a different slope than that.
Yeah, I see.
Yeah.
Hmm. So why choose the 80 to minus 12, or may I choose the 85 to minus 12 or minus 10 to get the slope?
So to calculate the slope, you could do any of these, anything from the line. Doesn't matter.
Yeah, I mean, may I choose the 85 minus 10 divide 36 minus 0?
85. Oh yeah, you could if it's on the line. I think what you're saying is on the line, but I'm not sure. The line doesn't go that far. But you cannot use the data points, right?
Yeah.
Yeah.
Or I can choose the 70 and choose another number. It's 30 is okay.
Yeah, but it's not 70. It's 70 point something, right? You'd have to make an estimate there. It'd be exactly 30, but then it's going to be 70 point, I don't know, 4 or something like that.
Yeah, but I mean, if you choose different, the data and the slope is different.
Say again?
Different answer. I mean, if you choose the different the data, then you will get the different slope.
No, you'll get within reasonable analysis, you get the same. It doesn't matter if you use this point and that point or this point and that point, you should get the same. Normally what I do, I would take the far point here and the close point over here, so I get a little bit of variability out of it. But it doesn't matter. The slope is the slope for that particular line.
Okay, thank you.
Yeah, you should try it. If you take 2 points over here and then you take 2 at different points, your values for M should be very, very close, if not the same.
Okay.
I have a question as well. Back up on page 20, you put like the middle of the page, and you said how many seconds does it take to get to 40 meters?
Mhm.
And you have y is equal to mx plus b, and then x is equal to y minus b over m. Is that, if nobody's guessed by now, I'm not good at math. So is that just known, or where did that come from?
Oh, how do I get from here to here?
Yeah,
Well, that's just algebra. So you're going
Okay.
to solve for x, right? So you subtract b from both sides. And then you have to get rid of the m away from the x, so you divide both sides by m.
okay.
Yeah? So this is just rearranged to get this. And then I just substituted the numbers in.
Okay.
Okay, well, I thought I should put something in here about percent as well. And I know everybody has problems with percent because you might have taken some sports and they want 110% of what you got, and that's not possible. You cannot give 110%. So what percent means is parts per hundred. So 1% of a dollar means that there's 1 part out of every 100 parts. So in other words, that's 1 cent out of every 100 cents, right? And so then we multiply by 100 to turn that into a whole number. Because if I take 1 divided by 100, I get 0.01. If I now take that and multiply by 100, then I get 1. So 1% really means you have 1 part out of every 100 parts, which would give you 0.01, but then you're multiplying by 100 to turn it into percent. So percent means parts per 100. Percent can also be used as a conversion factor because it's directly proportional. So I know you guys were really interested in all the Chihuahua stuff. So therefore, the top 5 breeds that bite most often are Chihuahuas, Bulldogs, Pit Bulls, German Shepherds, and Australian Shepherds. And I would say they bite for different reasons. Chihuahuas often bite because they're afraid. Sometimes they bite because they just feel like they've been abused all their life. Pit Bulls may bite for a different reason. German Shepherds, which I've owned, and my friend has an Australian Shepherd, I say they probably bite because they're afraid, although they can be taught to do things. So what is the percent of Chihuahuas in the US if 1 out of every 18 dogs is a Chihuahua? Okay, you get 1 Chihuahua out of 18 dogs, right? Multiply by 100, that's 5.6 of the dogs in America are Chihuahuas. How many Chihuahuas in the US if there's 89 million dogs and 5.6 of them are Chihuahuas? So you got 89 million dogs, and look what the percent does. What does that 5.6% mean? That means that there's 5.6 Chihuahuas out of every 100 dogs. Now dogs cancels out, I have Chihuahuas left over. There's 5 million Chihuahuas in the United States. In the year 2000, there were 68 million dogs in the US. And then by 2017, that had increased to 89.7 million. what is the percent increase during these 17 years? So the actual increase was 21.7 million, right? So the increase was 21.7 million compared to the start, which was at 68 million. So again, we're going to turn this into a percent, so we multiply by 100. The answer is the increase is about 32%. So according to the CDC, there's about 4.7 million dog bites per year in the US. 81% cause slight or no injury, 19% are treated and released, 0.01% require hospitalization, and 0.00058% are fatal. So how many fatal dog bites are there per year? Okay, I got 47 million bites, and here's the number that are fatal. That's 0.00058 fatalities out of every 100 bites. So that means that there's 2.7 times 10 to the fifth million fatalities. So if I were to turn that into a real number, that's about 27 fatalities per year from dog bites. Okay. Make sense?
Wait, why did you multiply the last part by 10 to the 6?
Oh, I just replaced million,
Oh, okay.
what it stands for.
Mm-hmm. Thank you.
Why, do you have a Chihuahua? So just some dumb stuff. Okay, Instagram and 10 roses instead of 12 because he wants to use the metric system. And then I just found out last night because my wife was on Facebook last night. One of her former students from Farrington had posted some stuff about this new SpaceX stuff that was going up yesterday, but they canceled it. And she's like, oh, don't you remember? Min works at NASA now. Yeah, so from Farrington to NASA. So she's involved in that space flight thing. She works for Lockheed Martin, which, by the way, I think that was the company that misused data. So in 1999, the $125 million Mars orbiter was lost. It crashed into the surface of Mars and was destroyed because Lockheed Martin gave its data for thrust in foot-pounds instead of newtons. They didn't use the metric system. Everybody else was using the metric system. They didn't. Cost a lot of money.
Professor, why do you suspect that the United States doesn't switch to the metric system?
Yeah,
I
man,
asked a good one.
complicated question. I forget how many years ago it was, but they did an experiment where they started pumping gas by the liter. And I'm just like, oh, I'm so happy we finally are moving into the metric system. Then about a year later, they stopped and went right back to the gallon again. It's like, what? I don't get it.
Professor, why don't you think we do better in education in America?
Why do we not?
Yeah, how come like we're number 27 out of like 50 countries? Like being that we're like such a developed country, like why aren't we more intelligent?
Well, it's not necessarily intelligence, but it's a matter of where you put your priorities, I think. You know, I look at my own students. I look at my wife's students, I look at my kids, I look at my grandkids, and the priority is not education. And you go to some of these other places, the priority is education. I remember when I first started teaching at the university, I'd have these Japanese students and they're like calling me sir and all these different things. I'm like, no, I'm just Harry. And they had a hard time with it because they respected teachers so much because they respected education. And now they don't. I've told people many times, if you were to get every scientist in the United States or the world to agree on one thing, some celebrity like Kim Kardashian would come along and diss it and everybody believes Kim Kardashian. Our priority's in the wrong place.
I don't believe Kim Kardashian.
Yeah, I know. So here's the other thing. So I'm on the board of directors for the Education Institute of Hawaii. And what we're trying to do is improve public education. And right now we have a lawsuit against the DOE and the superintendent, although we like her, because we want to know where the money goes and how it's used, and they don't have all the information. They don't want to give it to us. But we put on several conferences. One time we had an invited speaker. He was from Finland. And I don't know if you know this, but every year, Finland is #1 in education. So here we have an important minister of education from Finland. We're at the yacht club having dinner, buying them dinner, and I'm sitting right next to him and his wife. And he'd already given his conference, and I'm asking him, well, how do you guys do this? I mean, I was looking at some of the video that you showed, and your kids did not look homogeneous. They looked like a mixture of a whole bunch of kids, just like we look like in Hawaii. He goes, yeah, it's quite different than 20 years ago because of all the immigration and everything. So that wasn't the issue. So I said, well, what do you guys do different that we don't do in the United States? And he said, you know, we're a small country. We can't afford to do all the educational research that you guys do. But we're not stupid. We read everything that you guys produce. But the difference is you discover it, but you don't do it. We look at your stuff and we do it. So they're doing what we already know what is the best thing to do. But the difference is that they make it a priority. In the United States, we don't. Maybe especially so in Hawaii, I don't know. But it's a complicated issue, that's for sure. Anyway, just some more cartoons. Does anybody have any questions about anything now, this chapter? I'm not going to start the next chapter. So this chapter has a lot of skills in it. These skills may be called remedial, but it doesn't matter. If it's not remedial to you, then you're just going to have to just work that much harder. If it's easier for you, then yeah, fine. But I'm interested in getting the most remedial of you up to speed. And if you can do, if you can do these kinds of problems, where's that review? There you go. If you can do these kind of problems, you'll be okay. So the same methodology that we used here is going to be used in all the other chapters. Almost everything is a direct proportion. So far, the skill we have to have that is not a direct proportion is simply temperature conversions. So, yeah. So do you understand what I'm doing when I say one reason why students fail themselves, and trying to get you to think out of the box and makes you think what the math is really telling you? If you make that connection is yours forever. But for some reason, students bypass the learning part. They learn how to do the problems and fake their way through everything. But at the end, they don't really understand the math that they've been doing. So here's a situation that I noticed when my wife was still teaching at Farrington. So she takes care of her kids, man. These kids, they never forget her. So she was getting her kids into college, and she's like, yeah, you should test into calculus. So your first semester of college, you should be taking calculus. So then the student would go take the entrance exam and then not qualify for calculus. And then my wife's like, well, what's wrong with you? You took all these courses. So she would make the kids go back and study, to review everything, and then retake the entry exam, and then they would place in calculus or maybe even higher. And I started to think about that. It's just like,
No.
the reason is that math is taught wrong. What they're having you do is memorize procedures.
No.
When you're taught math, you're taught to memorize procedures. And then how long does memory last? Not very long. And that's the reason that your students are doing that problem.
for when is June 2nd.
Okay,
1 p.m. Okay, 1 p.m.
I got it, somebody.
Okay. Thank you. Bye-bye.
Sorry. Okay. So yeah, that's the problem. Math is taught wrong. It's not taught for understanding. It's taught to just memorize how to do stuff and then get through the class. That's all they try to do. And memorization doesn't last. Understanding is harder to do. It takes more time, but then it's yours forever. So let me just go past it. Oh, I'm not screen sharing, that's why. So do you understand why these are not direct proportions? This is y is equal to mx plus b. B is right there. An example of that was all the equations interconverting between the temperature scales. So here is the only direct proportion. So if I take the slope between here and here, it's the same as between here and here. And b is always 0. Okay. If I go to this, the slope here is different than the slope here, which is different than the slope here. Okay. So yeah, that's the difference. So a direct proportion, not a direct proportion. So if you have questions, I guess we can end it here then, a little bit early. If you have questions, you can ask them now. You can email me. If there are questions that you think everybody should see, then put them in the discussion part of La Lima, and I'll answer it there, and then everybody can see the answers. What I would like would be people put questions up there, and then other students help them solve the question themselves. They help, so the students are helping each other. That's the best way to do it.
Professor, when's our next meeting time?
Oh, I'd say we can do tomorrow. Yeah.
At 2 or noon?
Go at noon.
Okay.
I just had a meeting today.
Okay. Thank you.
Okay, so I'll see you folks tomorrow at noon if you're into it. Take care.
Thank you.
Thank you. See you.